Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad. Today I'm going to present about green retrofit proposal for a community hall by integrating solar energy and rainwater harvesting for sustainable resource management. So yeah, moving on to the next slide. So here is the part. Moving on to the introductions. Why? So why is this project? Again, I recall the project title is a green retrofit proposal for a community hall. Okay, so what is retrofit? Retrofit is basically upgrading old system to modern, eco-friendly ones. And when it created this project, it means to turning a wasteful hall into a sustainable hub for the community. Alright, community halls now use a lot of electricity and water, which leads to high cost and environmental impact. So the approach that we are choose to take is to amend or implement solar energy system and also the rainwater harvesting systems. So what are our goals? The goals are, the aim is to improve resource efficiency, reduce carbon emissions, and lower utility costs. Other than that, the project also supports sustainable development growth and green energy adoption. Okay, moving on to the next slide. Why is this project necessary? Right now, halls face big challenges: high electricity use, rising utility bills, and heavy water consumption. So mostly, the community halls rely on fossil fuels, which increase carbon emissions. And by retrofitting, we can cut bills, reduce waste, and also improve efficiency. This project is necessary to tackle this issue directly. Alright, and then this project also supports Malaysia's sustainability agenda. It aligns with the Green Technology Master Plan and the 12th Malaysian Plan. The foundation is clear to promote low carbon development, build resource efficient infrastructure, and encourage sustainable community growth. Okay, now we're going to talk about engineering economy principles, the principles behind this. So we apply engineering economy to compare retrofit versus new construction. Retrofit is cheaper, faster, and greener. We analyze cost, savvy, and payback period to ensure financial feasibility. Project management methods, planning, scheduling, risk assessment, keep everything on track. Together, this provides a strong foundation for success. Okay, now moving on to project plan proposal, integrating solar energy and rainwater harvesting for sustainable resource management.
Okay, so for the project overview of this project, we have two things upgrade, which is this one is the solar PV installation, where 50 kilowatt rooftop solar system will use, and then it generates renewable electricity and also it reduces annual electricity cost. While the second thing is the rainwater harvesting system. So we use 10,000 liters storage tank and water collection from rooftop gutters, and it will be used for cleaning, irrigation, and also toilet flushing. Okay, next is project scope, which includes planning, procurement, installation, testing, and also commissioning of both systems. Okay, so there are three scopes, which one is the civil and structural engineering, second is electrical engineering, and last one is the plumbing engineering. Okay, so the scope for the civil and structural engineering, we have the structural integrity assessment of the existing roof, installation of solar breaking mounts, area water tank foundations, and also minor trenching for underground plumbing. Okay, and the second one is the scope for electrical engineering, is installation of PV modules, inverters, and net metering switchgear. Also the general routing and integration of smart energy meter dashboard. Last one for plumbing engineering, the scope is to install the gutters, first flush, elevators, and filtration units, and it's dedicated for non-portable piping network to restrooms. And last one for integration of the booster pump system. Okay, next move on to the key milestones and also the deliverables. Okay, so this project starts with the project approval, where the proposal of the project is approved, and then move on to the site assessment, where the site survey report is done, and then after that we have the system design completion and also the procurement phase, where materials and equipment is purchased. Okay, after the procurement phase, we have the installation of the solar PV and also the water harvesting systems. After that, we have the system testing, where we test and inspect the report, and after that we also have commissioning and training and also handover. Okay, after training and handover, we close the project, where the final project report is being submitted. Okay, here you can see the detailed tasks and tweaks. So here are all the responsible party for this project. So the first one we have the project manager, engineering team, electrical engineer, civil engineer, financial analyst, contractor, and also the QA team. Okay, and at the right side of the slide, we also have the responsibility matrix, where I focus on to three responsibility party, which are project manager, engineers, and also the contractor. And here are all the activity that been done by these three responsibility party. Okay, so here is the total estimated project budget, which is 18,000 ringgit. And you can see here that the largest estimated cost is solar PV panels. Okay, and we also include items such as the price of the project manager, inverter, electrical components, mounting structure, pumps, piping, filtration system, and so on. Okay, and you can see here we also have a contingency fund of 10% of the total estimated cost, which is the 8,000 ringgit. Okay, and the next part of the slide also have the human resources and all the human resources that we need in this project. Okay, next we have the alternative comparison in this project. So the first one is in terms of solar technologies, and we propose two alternatives, which is the first one is the monocrystalline solar panel, and the second one is the polycrystalline solar panels. Okay, in alternative A, it offers higher efficiency, which is range between 20 to 24%, and it also has the longer lifespan compared to alternative B, and then it also has higher energy generation. However, it has higher initial investment costs than alternative B. Okay, when we see the alternative B, which is polycrystalline solar panels, it has lower purchase costs and it is suitable for large installation area. However, it offers lower efficiency and also requires larger roof area. So after we compare both alternative A was selected. Okay, next comparison is between the water storage system. So we propose two alternatives also, which is the polyethylene tank and also the concrete tank. Okay, in polyethylene tank, it has lower installation costs, lightweight and easy to transport, and also it is corrosion resistant. While the concrete tank is extremely durable, suitable for underground installation and high storage capacity, but the construction cost is higher than the polyethylene tank. So after we compare these two alternatives, we selected the alternative C, which is the polyethylene tank.
Alright, so the most important part in project planning is the work area structure and risk management. So what is WBS or work area structure is actually a framework that ensures all project elements and their relationships are well defined. So just bear in mind that we need to consider two aspects, functional and physical elements. So we have three charts to allow us to understand and see the functionality of the project, which is actually a combination of installing solar panels and water tank. And of course, before we conduct the experiment or conduct the project planning, we need to consider the risk management. So you see the identification, assessment, response development, and response control. Next. Alright, so this is the WBS chart. They are comprised of functional and work analysis. So I'll just briefly mention one by one. So first is actually about the solar gradients actually analysis. So you want to know how much sun can be obtained, and of course you need to understand how the roof orientation and how potential shading analysis work on solar panels. Then for the second functional analysis, we have the design analysis, design electrical circuit connecting from panels to the inverter for solar energy, and of course you have planning using AutoCAD to design the collection area, gutter and reservoir, right? And then the third one is the functional work analysis for the interconnection provision compliance, understand the utility regulations and navigate the codes for electrical design. And now let's move on to the work elements, solar panels installation. So we need to make sure that we position the solar panels accordingly and do the wiring and the inverter correctly. And lastly is actually the rainwater tank installation. So Alright, so this is now the project constraints part. So project constraints are divided into three: physical, structural, local constraint, budgetary constraints, and weather and environmental constraints. So next, I'll explain the resource allocation and resource leveling for our community hall green retrofit project. Resource allocation refers to the process of assigning available resources such as manpower, materials, and equipment to specific project activities. So this is very important to ensure that the project can be completed efficiently without causing any unnecessary delays or additional costs. So for this project, we use the heuristic resource allocation method. So this method allocates resources based on their availability and the priority of activities. So activities that have a greater impact on the project are given priority first. So for example, materials and equipment must be purchased before the installation work can begin. Besides that, resource leveling is used to balance the workload among team members and avoid scheduling conflicts. So since the solar PV installation and rainwater harvesting installation involve different teams, so both activities can actually be carried out simultaneously. So this helps improve productivity and ensures smoother project execution. So now we'll be looking at the resource plan and activity schedule. So the project team consists of one project manager, one civil engineer, one electrical engineer, two plumbers, four technicians, and five contractors. So each member has their own specific role to ensure the project runs smoothly. The project consists of 8 main activities starting from project planning, site inspection, design and approval, materials purchasing, installation of the solar PV system and rainwater harvesting system, system testing, and finally the project handover. So the estimated duration for these activities ranges from 1 to 7 days, depending on the complexity of the work involved. So this is the Gantt chart of our project. So the Gantt chart provides a visual representation of the project timeline and shows the duration of each activity. It helps project managers to monitor the overall progress and ensure every activities are completed according to the schedule. Now let's take a look at the network diagram and critical path analysis. So the network diagram illustrates the sequence and dependency of project activities. It shows which activities must be completed before the next activity can begin. So based on our critical path analysis, there are two possible paths. The solar PV route has a total duration of 27 days, while the rainwater harvesting route requires 26 days. So since the solar PV route has the longest duration, it is identified as the critical path. In one sentence, the critical path is the longest sequence of activities that determines the minimum time needed to complete the project. Therefore, any delay in the critical path activities will directly delay the overall project completion. And the timeline baseline for this project is 27 days, starting from day 1 and ending on day 27. This baseline serves as a reference for monitoring project progress and ensuring the project stays on schedule.
Next, we'll discuss implications of our proposed green retrofit project on both the organization and society. Starting with the organization, so the implementation of solar PV panels and rainwater harvesting system provides several long-term benefits to the local council. First, the solar PV system helps reduce the reliance on electricity from the national grid, which will lower the monthly utility expenses. Even though there is an initial investment cost, the project will offer a favorable payback period and improve return on investment ROI over time. As a result, the local council can devote the financial resources towards other community development projects. In addition, the water harvesting system reduces the dependence on treated potable water for non-drinking purposes such as toilet flushing and landscape irrigation. This helps preserve the valuable freshwater resources while lowering water-related operating costs. Moving on to the societal impacts, so the community hall can serve as an ideal platform to demonstrate renewable energy and water conservation technologies. This allows the public to observe practical sustainability solutions and increase the awareness of responsible resource management practices. The project can also encourage greater community support for future green initiatives. Furthermore, by reducing dependence on external energy and water sources, the project will strengthen community resilience, which it promotes environmental responsibility among current and future generations by contributing to the reduction of greenhouse gas emissions and encouraging sustainable living practices. Now let's look at how this project contributes to the Sustainable Development Goals, or SDGs, of the United Nations. The first is SDG 6, which is clean water and sanitation. The rainwater harvesting system encourages more efficient use of freshwater resources as it reduces the demand for treated municipal water and promotes the sustainable water management practices. Secondly is SDG 7, which is affordable and clean energy. So the installation of solar photovoltaic panels expands access to clean and renewable energy as it improves energy efficiency and helps reducing the greenhouse gas emission. Lastly, the project supports SDG 11, which is sustainable cities and communities. By incorporating environmentally friendly technologies into a public facility, the project contributes to greener communities and more sustainable urban resource management. In conclusion, this retrofit proposal demonstrates practical and sustainable solutions to improve the environmental performance of public facilities. Beyond reducing electricity and water consumption, it provides long-term economic benefits, supports effective resource management, and creates positive impacts on both the organization and the community. Overall, the project serves as a valuable model for future sustainable infrastructure development. That's all from us. Thank you.